two angles are supplementary to the same angle are congruent. I don't know why I couldn't read that. It's more than 4 words probably, but this is P. Then the confusion part for me, my brain was that it says A and C are supplementary to B, right? Those are the what? Those are the two angles that they're referring to up here. So this statement is what? Q. All right, two angles supplementary to the same angle are congruent is P. A and C are supplementary to B, that's Q. All right, now it's saying that A is congruent to C, right? Everybody okay with that? So if P, then Q, P is true, therefore Q is true. All right. Now let's look back at number 1. Let's look at some of these problems that we did down here now. Determine whether each conclusion is based on inductive or deductive. Students at Olivia's high school must have a B average in order to participate in sports. Olivia has a B average, so she concludes that she participates in sports. That's obviously what? Deductive. All right, I'm happy with you. All right, that's deductive reasoning. All right, let's look at number 3. Determine whether the stated conclusion is valid based on the given information. If not, write invalid. If a number is divisible by 4, then the number is divisible by 2. So what are we saying there? If a number is divisible by 4 is what? P. Then the number is divisible by 2. Q. 12 is divisible by 4. Therefore, Q. Is everybody okay with this? So that we would consider as what? Valid. All right, by the law of syllogisms, right? Or, I'm sorry, the law of detachment. If P, then Q. P, therefore Q. That's what we're looking at. Everybody's good? Nobody has any questions? All right, let's check out 5. Determine whether the statement of the stated conclusion is valid. If a beach is public, then it does not have a lifeguard. Bayview does not have a lifeguard. Therefore, Bayview is a public beach. Valid or invalid? What is it? Yeah, does everybody agree, right? Now, I'm trying to convince you that just writing the letters just simplifies the process, right? If a beach is public, then it does not have a lifeguard. Bayview does not have a lifeguard. That is referring to what? Q, not P. So it's not valid. All right, is everybody seeing how easy that is? All right, here we go. If a triangle is a right triangle, then it has an angle measure, has an angle that measures 9 degrees. If a triangle has an angle that measures 9 degrees, then its acute angles are complementary. All right. So if a triangle has a right triangle is what? If a triangle is a right triangle, I believe that would be P, right? Then it has an angle that measures 90. That's Q. If a triangle has a measure that's 90, that's what? Q. Then the acute angles are what? Complementary. That's what? R. All right. So we can say, if you wanted to write this, we could say if P, then Q, if Q, then R, therefore it would be what? That's exactly right. So you could say, if a triangle is a right triangle, then its acute angles are complementary. So everybody see how that works? If the acute angles of a triangle are complementary, then it is a right triangle. Is that true? Is number 7 true?
Yes.
If the acute angles of a triangle are complementary, then it is a right triangle. Well, let's just look at it just from a perspective of a triangle. All right, if we draw a triangle, I'm trying. And if these two angles right here are complementary, then what has to be true about this angle right here? Because the angles of a triangle add up to what? 180, right? Does that make sense? The angles of a triangle add up to 180. So if these two angles are complementary and it's a triangle, then that has to be 90 degrees. So that is in fact what? That is true. If a triangle is a right triangle, then the acute angles are complementary. That's true, even though we didn't have to do it. I appreciate it. If a triangle has an angle that measures 90, then the acute angles are complementary. True, right? All right. All right, so let's look at number 11. Vertical angles are congruent. Angle 1 is congruent to angle 2. Can we say that they are vertical angles? No, right? Because you can have two angles that are exactly the same that aren't vertical, right? All right, here we go. So that was false or not valid. All right, then there's just more of this. So let's look at this real quick. 13, a dental assistant noticed the patient has never been on time for an appointment. She concludes the patient will be late for her next appointment. What is that? Inductive. Good. 15, if Eduardo decides to go to a concert tonight, he will miss football practice. Tonight, Eduardo went to a concert. Edward missed football practice. What is that? Deductive. All right, you guys got it. Let's go to 19. If a figure is a square, then it has 4 right angles. Figure ABCD has 4 right angles. The figure is a square. False, right? Invalid. Anybody, seriously, anybody have any questions? Nobody? All right, 21. We'll just do a couple more. If you leave your lights on while your car is off, your battery will die. Your battery is dead. Therefore, you left your lights on while your car was off. Invalid, right? All right, that's good. If 75% of the prom tickets are sold, the prom will be held at the country club. 75% of the prom tickets were sold, the prom will be held at the country club. Valid. We all good with this? All right, let me see if there's anything harder. If the temperature drops below 15 degrees, then the school will be canceled. The temperature did not drop below 15 degrees on Monday. Is there any conclusion? School was not canceled on Monday. Is that valid? Now, can somebody tell me just why it's invalid? Why? Anything else could cancel school, right? Something else could come up, right? Does everybody see what I'm saying, right? So again, that's why it's got to be in that if P then Q, P is true, then Q is true. It's got to be in that order. All right, I like that. All right, let's look at 31. If you interview for a job, then you wear a suit. If you interview for a job, then you will update your resume. Is that the law of syllogisms? If you interview for a job as P, you will wear a suit is what? Q. If you interview for a job is what? Then you will update your resume. That's nothing. Does everybody agree with me on this? All right. So no valid conclusion. All right, let's look at 33. If two lines are perpendicular, then they intersect to form right angles. That's P. Q. Lines R and S form right angles. That's Q, correct? So does that have to be true? Because it's if P, then Q, right? Then what? Q. So we would say not valid. Bless you. Bless you, bless you. Not valid. All right, 35. If two lines in a plane are not parallel, then they intersect. So P, Q. If two lines intersect, then they intersect in a point. Q, R. So what can we say? If two lines in a plane are not parallel, then they intersect in a point. Thank you very much. All right. Everybody's good with that? All right. Hopefully that was okay for you guys. All right. Some years I do this, some years I don't with the kids. And I've noticed it coming up on the SATs, ACTs every once in a while. So I just decided to throw it in there for this year. All right. So again, those are all good things. I wanted it on your notes because I think it's good to refer back to them. Now, section 2-4 now. All right. And I've already told you what a postulate is. All right. Some geometry books call them axioms. All right. And it's just a statement that is accepted as true without proof. I've already told you that. All right. And the basic ideas about points, lines, and planes can be stated as postulates. And for the life of me, I was always stunned by the fact that these things, points, lines, and planes, can't even be defined. And we're accepting things without proof. And then all the other proofs are built upon things that we can't even prove are true. All right. So that was very difficult for me. All right. I know it's difficult for some of you. All right. If you're thinking about math. All right. But I can't help that. All right. This is called Euclidean geometry. When you go to college, you will take non-Euclidean geometry. All right. Which is completely different. All right. But here we just have to accept some things as true. All right. So with that being said, we're just going to read through these. And instead of calling them postulates or axioms, I just like to call them, this is just common sense. All right. This is common sense to me. All right. All of this is true. All right. So through any 2 points, there's exactly one line. All right. Does everybody agree? That's kind of makes sense, correct? Now, I used to try to blow this up a little bit and show you why and try to explain why they're postulates, right, instead of theorems, right? First of all, does everybody see that? I'm just highlighting, and there's those 2 points, and that line goes through it. Does everybody agree with that? Now, just watch for a second. I'm going to try to demonstrate something here. If I make that line now is really small that goes through, that's 2 points. Do I agree with that? Now, if I duplicate it, I'm going to come over here. Well, there's 2 lines that goes through those 2 points now. Does everybody see that? Right. So a point has to be as thick as the line. Does everybody agree with that? It's kind of right. So that's why they had to come to some agreement on this. All right. There's only one line that can be drawn through those 2 points. I don't care how thick the points are. Does everybody agree? All right. So that's kind of the justification of this. All right. Now, next. Now, this is what's important. And again, I like to try to tell kids the questions that are going to be on the test. Through any 3 points, there's exactly one plane. That would be what? That would be false. Now, why would that be false? Because look, if I put a 3rd point on this line that I just put on the one I was talking to above, does that define a plane? Does that define a plane? Now, the reason it does not define a plane, because think of it as like a box or something that was going through here, right? If I did that. All right, then I can draw another plane going through those 3 points like this, coming out the back and this way. And it's always kind of hard for me to draw 3-dimensional, but does everybody see what I'm getting at there? Right. All right, this line passes through many planes. All right, that's why when you do this, you have to say through any 3 non-collinear points. So that's the important part. All right, you're going to see true and false questions. I'm going to say through any 3 points, there's exactly one plane. And if you don't read carefully, you will miss the question. All right, they have to be non-collinear points. Now, is it possible to draw 2 non-collinear points? Is it possible to draw 2 non-collinear points? Not possible, because 2 points determine a what? Determine a line. So you can't draw 2 non-collinear. 3 non-collinear points is easy. That's 3 non-collinear points. All right, hopefully you're understanding. And like I said, as soon as you understand the definitions, I think it's easier. But if I'm saying non-collinear and you forgot what non-collinear, just let me know. All right, if you understand the words, the math is easier. It's that you don't understand the words that makes it harder. All right. So now a line contains what? At least 2 points. I say a line contains what? An infinite number of points. All right, I can put as many points on this line as I want. There's an infinite number. All right, I'm not sure why they say a line contains what? At least 2 points when I know there's an infinite. All right, everybody's good with that? Just like the next one, a plane contains at least 3 non-collinear points. I say a plane contains what? Infinite number of points. All right, they're telling you that a plane has to contain at least 3. All right. If 2 points lie in a plane, then the entire line containing those 2 points lies in that plane. Again, to me, all of this was just common sense. So if I'm looking here, does everybody agree that EC is in this plane? If I draw line EC, what's true? That's also in the plane. Agreed? All right, same thing with BK. That's in the plane. All right, I think all this is common sense. All right, now if 2 lines intersect, then their intersection is exactly what? 1 point. There's no way it can intersect in what? 2 points. All right, unless we were doing non-Euclidean geometry, then it could intersect at 2 points. All right. So if 2 planes intersection, then their intersection is a line. So I agree with that. All right, I tell kids, think about the front wall and the ceiling. If I take the front wall and the ceiling, that intersection is a what? Is a line. All right, simple as that. All right, now again, I used to call this common sense. All right, I'm not asking you to write down postulate 2.1. I'm not writing you to write down postulate 2.3. That's silly. All right. And you'll see they'll ask you if it's true or not. And if it's true, name the postulate. Do I care about naming the postulate? No, I just want you to know if it's true or false. You don't have to name the postulate. All right, now, today we're going to start off doing some algebraic proofs. All right. Now, this is not something we've spent a whole lot of time on last year, but we are going to review some of these, and hopefully you're agreeing with me. This is common sense. All right. These are called the properties of real numbers. If A equals B, and I add the same thing to both sides of the equation, it's still what? It's still equal. It's called the addition property of equality. The next one is what? Subtraction, then multiplication, then division. Now, a lot of kids look at this right here, and let me explain this right here. I'm not going to explain, I'm going to ask somebody. The division property is a little bit strange. All right, what does this C does not equal 0? Can someone tell me why they put that there? Tell me.
Because something can't go into 0, because then it would just be like.
That's true. Exactly. You can't divide by 0. Now, how do I remember you can't divide by 0? So here's what I do. 5 over 0 and 0 over 5. What's 0 divided by 5 and what's 5 divided by 0?
0 divided by 5.
What is 0? Exactly. And 5 divided by 0 we say is undefined. We don't know what that is. All right. So how do you remember this? If I say, for example, 2 goes into 8, it's automatically what? 4. So that came from 8 divided by 2. So in this case, 5 divided by 0 is 0 times what is 5? 0 times what is 5? Nothing. That's correct. That's why it's no solution. But if you do it the other way, 5 times what is 0? That's why that's true. So you never can divide by 0. You never can divide by 0. All right. So that's what this is saying. All right. You can divide by anything but what? 0. All right. The reflexive property just means you equal yourself. A is always equal to A. All right. The symmetric property of equality is what I use a lot with you guys when it came out to be like 4 equals X. I would just automatically write what? X equals 4. And that's what? The symmetric property. All right. The transitive property was kind of like the law of syllogisms. If A equals B and B equals C, then automatically what? A equals C. That's a transitive property. And of course, the substitution property, if A equals B, then B can be B can be replaced with any expression or equation. All right, you'll see that. And of course, we know the distributive property. We've done that thousands of times. All right, so again, those are just the properties. All right, those are the properties that allow us to make the proofs. All right, those are the properties that allow us to handle the proofs. So with that being said, let's jump into our problems here. All right, here you go. Explain how the figure illustrates that each statement is true. Then state the postulate that can be used to show that each statement is true. Once again, do I care that we look up what postulate it is? No, we're not doing that. All right, on the test, you're not going to have to memorize postulate 2 or postulate 2-3. No one does that. All right, you just have to understand the postulates. All right, so number 1, planes P and Q intersect at R. All right, first find plane P and then find plane Q for me. So plane P is the plane on the what? And Q is the one in the front. So those two planes intersect at R. Is that true? Now, part of the reason why I do this is not because I'm trying to show you anything. It's because I'm trying to show your eyes how we're dealing with 3-dimensional things here. And for some students, the 3-dimensional seeing is not easy thing. All right. So that's why I'm saying a lot of times what I do is I try to, if I'm having a little bit of trouble on these, is if you draw line R, right, and then you're able to draw the different planes, right? Here is this plane over here, and here's this plane over here. You can see the intersection. Does everybody agree with that? Your eyes might not be able to do it, but if you draw it, your overlapping parts is where they intersect. Is everybody good with that? All right, hopefully you understand what I'm saying. All right. So hopefully your eyes saw that. Lines R and N intersect at D. Find R, find N. Does that intersect at D? Is it possible to intersect at a different point? No, thank you. Line N contains the points C, D, and E. True or false? Yes. At least what? 2 points make a line. So we agree? Plane P contains A, F, and D. Everybody look at A, F, and D. Does plane P contain those 3 points? True. At least what? 3 points are on a plane. Or you could say 3 non-collinear points form that plane. Line N lies on plane Q. How do I know that line N, and here is line N, how do I know that line N lies on Q? Someone tell me. Nope, nope, nope. Tell me, Oliver. Good thought, though. Yes. All right, I like that. So he said that D, C, and E are in line, are in plane Q. Is that agreed? So if the points are in the plane, then what? The line containing the point is in the plane. Does that make sense? Anybody have any questions now? All right. So here we go. We got to move on. Determine whether each statement is always, sometimes, or never true. If the plane contains a line and the line contains a point, then the plane contains the point. If a plane contains a line, all right, so I'm going to try to look at this down here. If a plane contains a line, so let's just say AK is a line. If a plane contains a line and a line contains a point, so K is on the plane or is on the line and the line is in the plane, then the plane contains the point. What are you thinking? How can it not be always? Tell me what you think. Yeah, but M is not on the line. So here, let me make sure this is on. You're understanding me. If a plane contains a line, that means this line is on that plane. Do you agree with that statement? And K is on that line. Then K is on the plane. Yeah, I think that's always. Now, I'm not saying I'm right. I'm saying if you see it differently, I need to know so we can try to fix it, right? Because again, I can make mistakes on these. My eyes don't see this stuff very good. Or I don't like 3 dimensions. Is everybody okay with that? Anybody disagree with that now? If a point is on a line and a line is in the plane, then the point must be in the plane. Right? All right. I'm hoping that's good. A line contains 3 non-collinear points. A line contains 3 non-collinear points. Non-collinear means what? Not on the same line. So can it contain 3 non-collinear points? So that would be what? Never. All right, hopefully you're not just like daydreaming here, guys. I feel like some of you are daydreaming. I know it's not the most exciting thing in the world. I know it. All right, come on, concentrate with me. Is everybody okay with that? All right, you got to be thinking about it. All right, next. Line R contains only a point B. False, because it has to contain at least what? At least two. All right, I like that. All right, I like that. Okay. So now you can kind of read over 9, 10, 11, and 12 for me. All right, I need to get into the proofs. All right, here is what's called a flow proof. Guess what? We are never doing a flow proof. All right, so just cross this out. All right, we are going to do 2 column proofs. Always. We don't write paragraph proofs. We're not in English. All right, we're only doing what? 2 column proofs. All right. So what does a 2 column proof look like? You can flip the page. Here is my 2 column proof. Every 2 column proof, you list out statements and then you list out what? Reasons. All right. We are given this. Now here's your introduction, guys. Stay with me. We are given this. 5x minus 12 equals 8. We're trying to prove x equals 4. Because we are geniuses, we can look at that and say, that is obviously what? That's obviously true. Because we can just do the math in our head, which we've been doing. All right, but now we're doing something different where we have to explain what we did. All right, so here goes the explanation. Step number 1 always is going to involve the given. You have to simply write out the given. All right, which means some of you are not going to get zeros on the test because you'll just write down on every proof the given and I'll give you a point. All right. So all you have to do is know you're starting out with the given. So here we go. Why does 5x minus 12 equal 8? Why is that true? Because it's given. That is the reason. All right, now, why does 5x equal 20? We did the what? Addition postulate or addition property of equality. Oh, my iPad is having trouble. The addition property of equality. The addition property of equality. So basically, what did I do to both sides, guys? You added 12. So I'm going to show you something. All right, I'm not going to do this, but sometimes your geometry teacher, if you had a different geometry teacher, would want you to put this down. 5x minus 12 plus 12 equals 8 plus 12. All right, that would then be written as what? The addition property of equality. All right, now your geometry teacher, if you had someone different, might want you to then say that 5x equals 20. Now, how did I get from this step right here to this step right here? Your other geometry teacher might want you to say, well, that's just a what? Substitution. Why is that considered a substitution? Because what does negative 12 plus 12 equal? I'm substituting in equals. Does everybody agree? What does 8 plus 12 equal? 20. So I'm substituting in equals for equals. Is everybody with me on that? I don't care about that though. All right, I just want you to write 5x minus 12 equals 8. That was given. 5x equals 20. That's the what? That's the addition property of equality, which is perfectly fine with me. And then from there, you can say what? X equals 4 because we use the what? Hello? We use the division property of equality. All right. Now, what I want to do is I'm going to scroll back to what the book did. All right, because I want to show you something. You can have the same exact proof and write it differently than me, and we have both get it correct. Does everybody agree with that? All right. So this is what they were doing, like a flowchart proof. See, this would be what? Given. This would be the addition postulate, or I keep saying postulate, addition property of equality. Right. then this would be substitution. Does everybody see that? Do I really care about this substitution? No. All right. And then you would just say x equals 4 here by the division property. All right. Is that I'm just telling you, it's kind of easy. All right, it's kind of easy. But we are going to get to something a little bit more tricky. Write a flow proof. All right, JK is congruent to KL. If JK is congruent to KL, what does that mean? They are equal. Thank you very much. They are equal. All right, that's called the definition of what? Congruent. If something is congruent, if two shapes are congruent, then their side measures are what? Equal. All right, if two segments are congruent, that means their measures are what? Equal. You use measure as an equal. Shapes are what? Congruent. If you accidentally say line or segment XY equals segment AB, do I care that much? No, but some geometry teachers will mark that wrong because segments are not equal. They are what? They are congruent. Measures are what? Equal. Sides are what? Congruent. That's the main difference. So if something is congruent, its measures are what? Equal. And that's the definition of congruent. Did everybody hear what I just said? So we have to change, when it says congruent, we have to change it to equal by saying definition of congruence. All right, so how does that help? All right, so I'm going to scroll down here to the page right here where I cut this out for you. All right, on your next page, and I went ahead and wrote out the proofs for you. All right, I think it's annoying. All right, when you have to write all of it out. All right, I want it on that paper for you, ready to go. Okay, so what's true right off the bat? Someone tell me step number 1 and be a hero today. Step number 1. Oh, wait a minute. Aiden, tell me step number 1. You are amazing. Why is that true? Wow, okay. You guys are listening. What is going on here? All right, here we go. So everybody's going to write down segment JK is congruent to segment KL. And that is why again? Give it. Yay. On your first, you'll hopefully get one part right on the proof. All right, hopefully get one part right. All right, step number 2. Who's going to help me with step number 2? Uh-oh, Sebastian's going to jump in here. Sebastian, what is true? No. Help him, please. Uh-oh, Oliver. Equals what? No. Tell me. No. Nice try, Wheezy. Okay, no, here we go. I'm not expecting you to know this, but from now on you will. I'm talking about equals. Right now I have what? Congruent. So I need for you to say JK is equal to KL. All right. And that is, what do you know, Wheezy? JK is equal to KL. That is called the definition of congruence. Now we're talking about measures. Now that we're talking about measures, we can now say that what? 15 is equal to what? 3y minus 9, because we can perform a what? Yes, we can perform a substitution. All right, and like I said, guys, I don't know why kids hate this so much. It's just stuff you just have to write down now instead of just telling me. All right, you got to write out why. All right, so now my next step is what? So what's step 4, Coop? Well, what am I going to write down and add 9 to both sides?
15 plus 9 equals 3y minus 10 plus 9.
Or we could just say, because we are brilliant, 24 equals 3y. And now we would say that's what? Addition property of equality. We are brilliant. Step number 5. Come on, someone else be brave today. Uh-oh, we got someone brave in the back. Go. 8 equals y. I'm listening. It is the division property of equality. Now it's telling you to prove y equals 8. I am not done. Don't flip the page. Y does not equal 8 yet. 8 equals y. Therefore, step number 6, we're going to go ahead and write. No. Oh, thank you. Symmetric property of equality. Y equals 8. Symmetric property of equality. That is not that hard. All right, that is not that hard. So again, guys, finish up, please. All right, all of it. I'm just going to collect it tomorrow. If you're struggling, come in the morning. All right, 7:30. Get here. I'll help you write some proofs for you. Yes, tomorrow morning is basketball. Every morning, Tuesday, Wednesday, and Thursday.